Hello everyone, this is the second part of the hypothesis testing for one population series. In this video, we will discuss hypothesis testing for one population mean for small samples. Now, when is a sample size considered small? Yes, when n is less than 30. So when the sample size is small and the population standard deviation is unknown, that means we only know the value for S, which is the sample standard deviation, then we would be using the t distribution. So what happens when the population standard deviation or sigma is known? Yes, we would be using the normal distribution or the Z distribution. That means when the sample size is less than 30, we have two cases to consider, which is when sigma is provided or is known, then we would be using the Z distribution or the normal distribution. And when sigma is not provided or sigma is unknown, that means we only know the value for S or the sample standard deviation, then we would be using the t distribution. So the test statistics when the sample size is small and sigma is not provided or the population standard deviation is not provided would be the one previously, which is x bar minus mu over s x bar, where s x bar is s over square root of n. X bar would be your sample mean and mu is your population mean. S is your sample standard deviation and n would be your sample size. So the critical value of t would be determined by the degrees of freedom, which is n minus 1, similar to the previous chapter. Now let's look at an example. A waterworks officer insists that the average, so we will be testing the mu, daily household water use in a certain country is at least 400 gallons. So what is at least? At least would be mu greater or equals to 400 gallons. That means the alternative would be mu less than 400 gallons. So to check this claim, a random sample of 25 households was checked. So the sample size is 25. Now the average of those sampled was 380. So this is the average, but this would be the average of the sample, which is x bar. X bar is given as 380 with a standard deviation of 62. So this is also the standard deviation of the random sample. So this would be S 62. Is this consistent with the officer's claim? Remember what was the claim again? It was at least 400 gallons. So this is the claim. Claim is true. And this is when the claim is false. This is the first step to determine the null and alternative hypothesis and to extract all the values provided. And the next step would be to determine the distribution that we would use. When the sample size is less than 30 and sigma is not provided, only S is provided, we would be using the t distribution. So t star would be, I will write the whole formula once. So x bar minus mu over S over square root of n. x bar is 380, and our mu is 400 over s is 62 over square root of 25. So the value is negative 1.6129. And what's the next step? Yes, it is to determine the rejection and non-rejection region. So this is the t distribution. How do we determine the rejection and non-rejection region? We look at the alternative hypothesis. This is less than. That means the rejection region would be on your left hand side, right? And we now would determine the critical point, which is also T alpha. So what is alpha? 2.5%, 0.025. And what is the degrees of freedom? The degrees of freedom would be n minus 1, which is 24. So let's check the T distribution table. The degrees of freedom is 24 and alpha is 0.025. So the critical value would be 2.064. But look, the rejection region here is on the right hand side. So what we have here is the rejection region on the left hand side. And for your T distribution, the mean is 0. That means the value here would be a negative value, which is negative 2.064. The next step is to compare the test statistics with the rejection region. So negative 1.6129 falls somewhere here, which is in the non-rejection region. T star falls in the non-rejection region. So we accept the null hypothesis. Now when we accept the null hypothesis, we reject the alternative. The next step would be to answer the question. So is this consistent with the officer's claim? So because we accepted the null hypothesis, we would conclude that the claim is true, or this is consistent with the officer's claim. Okay, this is a past year question. The question says, a manufacturer claims that on average, the thickness of the spearmint gum it produces is 0.750 millimeters. So this is the claim, and this would be the null hypothesis because mu is equals to 0.750 millimeters. A quality control specialist regularly checks this claim. On one production run, he took a random sample of 10 pieces of gum and measured their thickness and obtained the data below. Okay, so we have a random sample of 10 pieces of gum. This would be sample size equals to 10. Now the question is, does the data support the manufacturer's claim at 0.05 significance level? What is the claim again? The claim is mu is equals to 0.750. So this is when the claim is true. I would write this sentence because it's easier than to make a conclusion later on. So the alternative would be the opposite of equals to, which is not equals to 0.750 is when the claim is not true or false. In this question, you are not provided the value of the sample average or X bar. You are also not provided the value of the sample standard deviation or S. So we need to calculate them from this data provided. So let's calculate the sample mean or X bar. X bar is equals to the summation of all of your data values divided by the number of samples. That means you would add up 0.765 with the second data, 0.760 with the third one, and up to the last value, 0.769, and you divide with the number of samples, which is 10. You could calculate this manually, or you could use the mode ST function in your FX570 MS calculator, or the statistics mode in the 570 ES calculator. 7.595 divided by 10, which is 0.7595. Next is to calculate the sample standard deviation. This is simply the square root of the squares of each of the summation of squares of each of the value. So you would square 0.765 plus 0.760 square, and you would add this up to the last value here, 0.769 square. You would minus this with the sum of all of the values again, 0.765 plus up to the last value there, 0.769. You sum all of the values and then you square the sum, divided with the sample size and divided with the n minus 1, which is 9. And the answer is the square root of 5.7694 minus 7.595 square divided by 10 divided by 10 minus 1, which is 9. And the answer is 0.0107. Based on our calculation just now, the value of X bar was 0.7595 and the value of the sample standard deviation was 0.0107. Then the next step is to calculate the test statistics. X bar minus mu 0.750 divided by S 0.0107 over square root of the sample size, which is 10, and the value is 2.8076. And the next step is to determine the rejection and non-rejection region. So your rejection region would be a two-tailed rejection region, where one part of the tail would be alpha over 2. So this would be alpha over 2 Alpha is 0.05, so alpha were to be 0.025. This would be 0.025. And the degrees of freedom, df, would be n minus 1, which is 9. So we would look for t 0.025, degrees of freedom 9. So when the degrees of freedom is 9 and alpha O2 is 0.025, the t value is 2.262. So this is 2.262. This would be negative 2.262. So let's make a decision. Your test statistics falls in the rejection region, somewhere there. T star falls in the rejection region. So we reject the null hypothesis. And we need to answer the first question. Does the data support the manufacturer's claim? So because we reject the null hypothesis, we would accept the alternative. That means the claim is false. The data does not support the manufacturer's claim. There's another question here which asks whether the result in 1 here would change when alpha is 0.01. Let's check. When alpha is changed to 0.01, the null and alternative and the test statistics remain, except for the area of the rejection and non-rejection region. So it is still 2-tailed because the alternative is not equals to, but now this is no more 0.025, this is 0.01 divided by 2, which is 0.005. What are the critical values then? The degrees of freedom would be 10 minus 1, which is 9, and alpha is 0.005. So when the degrees of freedom is 9 and alpha is 0.005, the critical point would be 3.250. This is 3.250 and negative 3.250. Let's make a decision. Now T star falls in the non-rejection region because it's smaller than 3.250. So when T star falls in the non-rejection region, we accept the null hypothesis. If you still remember, when mu is equals to 0.750, this is the manufacturer's claim, or claim is true. So we accept the null hypothesis, we reject the alternative. That means the claim is true. So we would now answer the second part of the question. Would your result in number 1 change at the 0.01 significance level? If you still remember, just now we rejected the null hypothesis and we accepted the alternative. But now the answer is the opposite. So the result in 1 change at alpha 0.01. Okay, let's discuss the next puzzle question. It says, periodically, the Melaka Water Department tests the drinking water of homeowners for contaminants such as lead. The lead level in water specimens are collected for a sample of 25 residents of Bukit Berang. So your sample size would be 25. N is equals to 25. A consultant claims that the mean lead level did not exceed 7.7. So what is not exceed? Exceed is greater than, and you have equals to and less than. So if it does not exceed, it would be less or equals to. So we have H null as mu less or equals to 7.7, and the alternative would be the opposite of that, which is greater than 7.7. So when is the claim true? When it does not exceed. So the null hypothesis is when the claim is true. The alternative is when the claim is false. Okay, again, we are only given the sample size. We need to calculate the values of the sample mean and the sample standard deviation ourselves. So let's do that. We have the sample mean as the summation of all of our data, 8 plus 9 up to the last value here, 6 divided by the sample size, which is 25. Using your calculator, using the SD function or the stats function in your calculator, you would get the sample mean as 7.2. And the sample standard deviation is the square root of the sum of squares of all of the values, 8 square plus 9 square up to the last value here, 6 square minus the square of the sum of all of the values, 8 plus 9 plus the last value 6 divided by the sample size 25 over the sample size minus 1, which is 24. The answer is 1.1772. Okay, so question A says find the sample mean, which we already found, and the sample standard deviation, we already know the value. So question B, test at the 5% significance level, so this is your alpha, whether the claim of the consultant is true. So let's do that now. The next step is to select our distribution. We have the sample size as less than 30, and we only know the value of the sample standard deviation, so we would use the t-distribution. So the test statistics would be x bar 7.2 minus mu 7.7 divided by s over square root of sample size, which is negative 2.1237. And next, we determine the rejection and non-rejection region. The t-distribution, mean is 0, and the rejection region will be on your right hand side. This would be alpha 0.05. So let's look at the t-distribution table. The degrees of freedom would be n minus 1, which is 24. So when alpha is 0.05 and n is 24, the critical point is 1.05. 711. And the next step is to make a decision. So our test statistics definitely fall in the non-rejection region because it's negative. So we accept H null. If we accept H null, we would reject the alternative. That means the claim is true. Let's look at the question. Test at the 5% level of significance whether the claim of the consultant is true. So the claim is true. That's our conclusion. Look at question C. What is your conclusion if the level of significance is decreased to 1%? Show your working steps in detail. So we would have the same null and alternative as before. The same test statistics. Rejection region on your right hand side. But now alpha is 1% or 0.01. Degrees of freedom is 24. The critical point is 2.492. The next step would be to make a decision. So the test statistic again falls in the non-rejection region. We accept the null hypothesis. That means we reject the alternative. And if we still remember just now, this was when the claim is true. So the claim is true. If we look at the question again, question C we've answered, we've showed our working steps in detail. And we have already made our conclusion that the claim is true. So let's answer question D. How would the level of significance affect your decision? In this example, the level of significance does not have any effect on our decision because in both cases, the test statistics falls in the non-rejection region. So that is what I'm going to write. In this case, alpha has no effect on the decision. So please justify your answer. In both cases, when alpha is 5% and when alpha is 1%, we accept the null hypothesis. Okay class, I just had an interesting idea. What if now, instead of the claim that the mean lead level did not exceed 7.7 microgram, I change it to the claim is less than. So our alternative hypothesis would be mu is less than 7.7. The null would be the opposite. This is when the claim is true. So the null would be when the claim is false. So the claim could be true when it is at the alternative hypothesis. The null hypothesis must have the equal sign. Test statistic remains as negative 2.12372. When alpha is 5%, our rejection region would be so degrees of freedom is 24. So our critical point would be negative 1.711 because it's on the left hand side. So the test statistic falls in the rejection region. We reject the null hypothesis. Is the claim true when we reject the null hypothesis? The claim is true. Now let's look at question C. What is your conclusion if the level of significance is decreased to 1%? If the level of significance is decreased to 1%, what's our new critical point? At 1%, our new critical point is negative 2.492. Let's make a decision. Our test statistic will fall in the non-rejection region. So when alpha is changed, the test statistic falls in the non-rejection region, and we accept the null hypothesis. If we accept the null hypothesis, then the claim is false. In this case, the level of significance affects our decision. What can we learn here? As our level of significance decreases, the probability of rejecting the null hypothesis will also decrease. So it's easier to accept our null hypothesis. Let's look at another example. Based on experience, the average weight of fish caught by Mr. Ali is 3.9 kilograms. He claims that the average will not exceed 3.9 kilograms. So what is not exceed? Exceed equals to and less than. So not exceed will be less of equals to. Less of equals to 3.9. So this is at the null hypothesis because it has the equal sign. So the alternative would be the opposite of this, which is greater than 3.9. Encik Ali's claim is that the average will not exceed 3.9 kilograms. This is when the claim is true. I usually write it here because then it's easier to make a conclusion later on. Claim is false for the alternative. And again here, you are not given any other information, so you would have to calculate that yourself. The sample size would be 10 and x bar would be the summation of all of your values. Divided by the sample size, which is So I would like to invite everyone to calculate this using your calculator, using the SD or stat mode. 4.37, and the sample standard deviation would be the square root of 5.6 square plus 4.2 square up to 3.4 square minus the summation of the values, the whole thing square, divided by the sample size, divided by n minus 1. The answer is 0.7973. And the next step is to determine the distribution to use. So in this case, the sample size is small and we only have the value of the sample standard deviation. So we would be using the t distribution. T star would be x bar 4.37 minus mu 3.9 over s 0.7973 divided by square root of 10. And the answer is 1.8641. The next step is to determine the rejection and non-rejection region. So we have the t distribution here. The alternative says mu is greater than 3.9, so your rejection region will be on your right hand side. Alpha is given as 0.05, so the degrees of freedom would be n minus 1, which is 9. So when the degrees of freedom is 9 and alpha is 0.05, the t distribution gives the critical value as 1.833. 1.833. And now we make a decision. So the test statistic falls in the rejection region. We reject the null hypothesis. So if we reject the null hypothesis, then we would answer this question. Do you think that Mr. Ali's claim is true? So Mr. Ali's claim is false. See, it is so much easier to make a decision if you write it out on your right hand side, like I did just now. Okay, that's all from the second video of the hypothesis testing for one population series. Thank you for your attention. I'll see you in the next lecture video.